Hello, good morning. So now we are going to discuss formative exercise 2.4 from textbook page 75. Okay, so question number 1, the diagram on the right shows a part of the curve y equals to square root x plus 1. The tangent and the normal to the curve at point P01 intersect the x-axis at Q and R respectively. Find the first one, the equation of the tangent and the coordinate of Q. Okay, to solve this question, first of all, you have to analyze the diagram first. Okay, so from the diagram you can see the pink line is a curve, the blue straight line is a tangent, and the green straight line is a normal at point P. Okay, so the first one A, we are going to find the equation of tangent. Equation of tangent is straight line, so y equals to mx plus c. Find m first. M is gradient and gradient is dy dx. Okay, so find dy dx first. Y equals to x plus 1 power of half. So dy dx is 1 over 2 x plus 1 power of negative 1 over 2 times 1. So here we simplify. We get 2 square root x plus 1. Okay, at point P here we have point P is 0, 1. Coordinate x is 0. Okay, so we substitute 0 plus 1. Okay, so therefore the gradient dy dx is 1 over 2. Okay, dy dx is gradient of tangent, and just now we are going to find equation of tangent. Equation of tangent is y equals to mx plus c. Okay, now we already have m gradient, which is 1 over 2, but c we are going to find the y-intercept. But from the diagram here, we can see for the blue straight line, the y-intercept is 1. Okay, so meaning that c is 1. So we just substitute into the equation 1 over 2x plus 1. Okay, so find the coordinate of Q. Okay, so coordinate of Q, coordinate of Q. Coordinate of Q is x-intercept. Okay, x-intercept y equals to 0. Substitute here, 0 equals to 1 over 2x plus 1. So then x equals to negative 2. So therefore, coordinate Q is negative 2, 0. Okay, 1b, find the equation of the normal and the coordinates of R. Okay, equation of normal is a straight line, the green straight line. So, equation of straight line is y equals to mx plus c. Okay, to find equation of normal, you have to find the gradient of normal first. And previously from A, we already have the gradient of tangent is 1 over 2. So we have relation product of tangent and gradient of tangent and normal is negative 1. So gradient of tangent times gradient of normal is negative 1. Gradient of tangent 1 over 2. So gradient of normal is negative 2. Okay, so equation of normal y equals to mx plus c. Okay, now we already have m, which is equals to negative 2, and c is y-intercept. Okay, from the diagram, the straight line for straight line, green straight line, y-intercept is 1. So c is 1. So therefore, equation of normal, y equals to negative 2x plus 1. Okay, to find coordinate of R, so coordinate of R. Okay, coordinate of R is x-intercept. Okay, x-intercept y equals to 0. So then we substitute y 0. So negative 2x plus 1. So then x equals to 1 over 2. So then point R is 1 over 2, 0. 1c, find the area of triangle PQR in unit squared. Okay, so to find area of triangle, there are many ways. Okay, maybe you can use the formula that you have learned in coordinate geometry. So that 1 over 2 times, then you arrange all the points. But now I'm going to show you the simple by using simple formula of area of triangle. Okay, so we have area of triangle, area of PQR. Okay, formula 1/2 times base times height. Okay, so now previously from A and B, you already have point R. R is 1/2, 0. Q is -2, 0. Okay, so the base is from Q to R. Okay, we add, okay, base is 2 plus 1/2. Okay, because base is distance, so we make it -2 is 2. Okay, so because the distance only is positive. Okay, height is 0p, or point OP. Okay, the height is 1. Okay, this one we get 5/4 unit squared. Question number 2, the diagram on the right shows the curve y equals to x squared. Okay, y equals to x squared minus 4x plus 1. Okay, with its tangent and normal at point P, AB. The tangent is perpendicular to the line to y equals to 4 minus x, and it meets the x-axis at B. The normal line meets the x-axis at C. Find the values of A, B. Okay, meaning that we are going to find the coordinate of P. Okay, so before that, we have to understand the question. Okay, given the tangent is perpendicular. Okay, the pink curve, but the pink line is a curve. The blue straight line is a tangent. And the green straight line is a normal at point P. Okay, so now given here tangent perpendicular to line this. Okay, so meaning that there is another straight line that perpendicular to the tangent, which is the blue one, the blue straight line, meet at axis at P. Okay, so therefore here we have another straight line. Okay, perpendicular to tangent at point B. Okay. So now we focus at red straight line. Okay. So the red one is given 2y equals to 4 minus x. Okay, the red straight line. So y equals to -x/2 plus 4/2 is 2. Okay, from here we can see the straight line, the red straight line, the gradient is -1/2. Okay, -1/2 actually gradient of normal. Okay, normal gradient. So gradient of normal. Okay, so to find gradient of tangent, we use gradient of normal times gradient of tangent equals -1. So normal is 1/2 times gradient of tangent is -1. So gradient of tangent equals to 2. Okay, so like this. Okay, gradient of tangent, we know that gradient of tangent is dy dx. So then we can find gradient dy dx from the equation here. Okay, y equals to x squared minus 4x plus 1. So dy dx equals to 2x minus 4. And dy dx is gradient, which is we already have just now, which is equals to 2. So then we can find coordinate of x, which is 6/2 is 3. Then to find y, so we substitute into the equation. So y equals to 3 squared minus 4 times 3 plus 1. So this one 9 minus 12 plus 1 is -2. Okay, so therefore A is 3 and B is -2. Then to B, find the equation of the tangent at P and the coordinates of B. Okay, tangent at P. So we need the value of coordinate P. Okay, just now we already have A and B. So then P is 3 -2. Okay, 3 -2. Okay, so equation of tangent, y equals to mx plus c. So we substitute, okay, y equals to mx plus c. Just now, y is 2, okay. M is gradient of tangent. Gradient of tangent is 2. Okay, gradient of tangent is 2. X is 3 plus C. So C equals to negative 8. So therefore equation of tangent is y equals to 2x minus 8. This is equation of tangent. Okay, then coordinates of B. Coordinate of B. Okay, coordinate B of B is x-intercept. X-intercept y equals to 0. So 0 equals to 2x minus 8. So x equals to 4. Okay, so therefore B is 4, 0. Okay, then number 2C, the equation of the normal at point P and the coordinate of point C. Okay, equation of normal, same, y equals to mx plus c at point P. P is 3, negative 2. Okay, so previously we already have value of gradient of normal, okay, from A. From A, just now, okay, gradient of normal is this one, okay, negative 1 over 2. Okay, so we substitute y is negative 2, negative 1 over 2, x is 3 plus c. Okay, so C is negative 2 plus 3 over 2. C is negative 1 over 2. Okay, so therefore, equation of normal is negative 1 over 2x minus 1 over 2. So to find coordinate of C, so y equals to 0. So 0 equals to negative 1 over 2x minus 1 over 2. So x equals to negative 1. So therefore, coordinate C is negative 1, 0. Okay, 2D, the area of triangle BPC. Okay, BPC, we need all the information that we already have from previous question. So point B is 4, 0. Okay, C is negative 1, 0. Okay, point P is 3, negative 2. Okay, so then to find area of triangle, so area equals to 1 over 2 times base times height. Okay, so 1 over 2 times base is the length of C2B. Okay, so 5. Okay, height is this one. So coordinate of y. But this one, height is always positive, so we take 2. Okay, so then the area is 5 unit squared. Number 3A. The diagram of the right shows an open box. Okay, open box with a square base of side x centimeter and a height of h centimeter. The box is made from a piece of cardboard with an area of 75 centimeters squared. Okay, so show that the volume of the box V is given by V equals to 1 over 4, 75x minus x cubed. Okay, so first of all, you have to use the information given, which is the total area is 75. Okay, so here is a cuboid. Okay, area 75. Okay, cuboid. This is open box. Okay, so perimeter P, let's say P. The bottom one is x squared. Okay, so then we have 4 side of h times x. Okay, so xh equals to 75. Okay, so here maybe we can make h as subject. So for xh equals to 75 minus x squared. H equals to 75 minus x squared over 4x. Okay, so the volume of cuboid is x squared times h. So then we substitute h is 75 minus x squared over 4x. Okay, so then we can simplify. We get 1 over 4 75x minus x cubed. Okay, so therefore shown. Okay, B, find the value of x such that the volume is maximum. Okay, the clue is maximum volume and also the maximum volume of the box. Okay, so we know that to find maximum or minimum, differentiate equals to 0. Okay, just now we have V from previous question from A. Okay, V equals to 1 over 4, 75x minus x cubed. Okay, so 75 over 4x minus 1 over 4x cubed. So we differentiate, so we get dv dx, 75 over 4 minus 3 over 4x squared, okay, equals to 0. So 75 over 4 equals to 3 over 4x squared. Okay, so then x squared equals to 25, x equals to plus minus 5, but x is side, so x equals to 5. Okay, so then is that maximum? Okay, then we can differentiate another time. Okay, so we get d squared v dx squared equals to negative 6 over 4x. Okay, then substitute. We get 3 over 2. X is 5. We get negative 15 over 2. Okay, negative 15 over 2 is less than 0. Okay, less than 0. So, maximum. Okay, but the value of maximum volume, we substitute V maximum, okay, into V. Just now this is V. Okay, so 1 over 4. 75x, x is 5, minus x cubed. Okay, minus x, x is 5. 5 cubed. Okay, which is equals to 62, 1 over 2. Okay, number 4, the diagram on the right shows a plank AB of length 10 meter living on a wall of a building. The end A is y meter from the level of the ground and the other NB is x meter from the foot of the wall C. Find the rate of change of NA of the plank if NB slides away from the foot of the wall at the rate of 3 meter per second when x equals to 8. Okay, so for this question, the clue is rate of change. Okay, and already given from the diagram x. So this one is delta x and the vertical is delta y. Sorry, dy dx. Okay, sorry. dx dt and this one dy dt. Okay. So x is dx dt is 3. Okay, so then you are going to find rate of change of NA, meaning that we are going to find dy dt. So now from the diagram you can find the relation of this is triangle. So we can find x squared by using Pythagoras theorem. X squared plus y squared equals to 10 squared. Okay, so y squared equals to 10 squared minus x squared. So y equals to square root 100 minus x squared. Okay, so then we can differentiate. Okay, so minus x squared power of half. So dy dx equals to 1 over 2, 100 minus x squared power of negative 1 over 2 times negative 2x. Okay, so this one we can simplify. Negative x over 100 minus x squared power of half, or square root 1 over 2. Okay, negative x over square root 100 minus x squared. Okay, so this one we have x equals to 8. So we substitute negative 8 over square root 100 minus 8 squared. Okay, so here we get negative 4 over 3. Okay, so now we are going to find dy dt. So we use chain rule. Dy dt equals to dy dx times dx dt. So then equals to negative 4 over 3 times just now 3. Okay, so 3. So dy dt equals to negative 4. For question B, you have to find the rate of change of n of b. Okay, so this one dx dt, we are going to find dy dt given equals to 2. Okay, so by using the same relation, Pythagoras theorem, x squared plus y squared equals to 10 squared. So x equals to 100 minus y squared square root. Okay, so x equals to 100 minus y squared power of 1 over 2 dx dy. Okay, because we have x in terms of y, we differentiate, we get dx dy is 1 over 2 100 minus y squared power of negative 1 over 2 times negative 2y. Okay, so we simplify negative y over square root 100 minus y squared. Okay, given y equals to 6, so here 100 minus 6 squared. Okay, we get here negative 3 over 2. It's a negative 3 over 4. Okay, so then we use dx dt equals to dx dy times dy dt. Okay, so but dy dt actually slide down. Okay, so actually negative 2 here, negative 2. Okay, so negative 2. So this one, negative 3 over 4 times negative 2 is 3 over 2. Now let's do question number 5. The diagram on the right shows a helicopter at a height of 135 meter from the ground. Okay, the helicopter moves horizontally towards the boy at the rate of 17 meter per second. Find the rate of change of distance between the helicopter and the boy when the horizontal distance between the helicopter and the boy is 72 meter. Okay, so now let's say now the clue is red. Okay, so red here. So let's say this is x and this is y. Okay, so rate of x is dx dt. Okay, move to the left, so negative 17. Okay, here we have right angle triangle, so we can we know that relation is by using Pythagoras theorem. X squared plus 135 squared equals to y squared. Okay, so y equals to x squared plus 135 squared power of half. So then we can find dy dx equals to 1 over 2 x squared plus 135 squared. Okay, power of negative 1 over 2 times 2x. Okay, so then we simplify, we get x over square root x squared plus 135 squared. Okay, so given x is 72, so we substitute equals to 72. So 72 over 72 squared plus 135 square root is 72 over 153 is 8 over 17. Okay, so now we are going to find the rate of change of y. Okay, so then dy dt equals to dy dx times dx dt. Okay, dy dx is 8 over 17 times negative 17. Okay, become negative 8.